Hello everybody. In this video we are going to be looking at the solution for the honors electromagnetic induction due right now number 1. We have a 500 turn circular loop coil 15.0 centimeters in diameter is initially aligned so that its axis is parallel to the Earth's magnetic field. In 2.77 milliseconds, the coil is flipped so that its axis is perpendicular to the Earth's magnetic field. If an average voltage of 0.166 volts is induced in the coil, what is the magnitude of the Earth's magnetic field at that location? A couple of things I want to point out in this problem before we get going is that initially the coil is parallel to the Earth's magnetic field, which means that there are no magnetic field lines going through the coil. So at that point, the flux is at its minimum or zero for its value, and then it's turned at 90 degrees so that the coil is perpendicular to the Earth's magnetic field. And when it is perpendicular to the magnetic field, you have the maximum number of magnetic field lines flowing through the coil, so the magnetic flux is at its maximum value. So in this problem, we are given the number of turns on the coil, which is 500 turns. We are given the diameter of the coil, 15.0 centimeters, which we do need to convert to meters. And in order to find the area, because it is a circular loop, it's a circle, so we need to find the area. We're going to need to know the radius. Radius is half of the diameter, so my radius for the coil is going to be 0.075 meters. The time it takes for it to rotate 90 degrees from parallel to perpendicular is 2.77 milliseconds, and I do need to convert that to seconds, so that is going to be 2.77 times 10 to the minus third seconds. And my induced EMF is 0.166 volts. In order to solve this problem, we are going to need to use Faraday's law of electromagnetic induction. And I know that epsilon, and remember this symbol right here, the Greek letter epsilon is my symbol for induced EMF. So my induced EMF is going to equal the negative of the number of turns times the change in the magnetic flux divided by the change in time. And because I know that magnetic flux is equal to the magnetic field times the area of the coil, I can replace B times A for my delta phi in the equation. And because my initial value for the magnetic flux was 0, the change in the magnetic flux is the same as my maximum value. So I want to solve this equation for the magnetic field. When I do that, I'm going to have B is equal to epsilon times delta T divided by the negative of the number of loops times the area. I'm going to plug my known values into the equation. And one quick note on this problem, I have incorporated my formula for the area into the equation itself. You can calculate that out separately. It will come out the same. Doesn't really matter, but remember the area of a circle is pi r squared. So here is my pi, there is my radius, and I am squaring it. So when I plug that into the equation, I should get a value of the Earth's magnetic field at negative 5.2 times 10 to the minus 5th Tesla.